Understanding the problem. This problem will be an exercise of signal knowledge, communication links, and modulation schemes. You are given a complete communication system and provided with basic parameters. You are asked to calculate the intermediate signals, parameters regarding the communication link, and finally comment on the modulation scheme that is used in the system by proposing an appropriate demodulator. Before going any further, let us write what we are given and calculate some common parameters, which we will likely use in the solution. Wavelength is surely used in link budget calculations. It is good to write down the transmitted signal ST explicitly. DSP signal before the power amplifier is the signal ST. You shall take its Fourier transform and draw its spectrum on a graph. You should refer to the formula sheet you are given for finding the Fourier transform. In the previous slide, we showed ST in time domain. All other parameters are provided in the question. Refer to your formula sheet to see how the average power of a signal in the form some constant times a cosine is calculated. Our signal ST has two cosine terms in it, each having a constant multiplier of 1/2. So, from this observation you can use this average power formula to find the power of the DSP signal ST. Before doing this part, you may find it useful to read the question once again and understand how the communication system is set up. After you put the block diagram, it will be easier to write down the link budget. From this link budget, you should be able to calculate the path loss and received signal power. You may refer to your lecture notes to see what a typical DSP receiver consists of. Or you can inverse the operations of the modulator to get to the demodulator yourself. In any way, the typical DSP receiver is a mixer followed by a low-pass filter,